Ms. Anjali Chandra is former member Punjab Electricity Regulatory Commission, and she brings to the table 4 decades of experience in the power sector. Ma'am has the areas of expertise include distribution and transmission network planning, formulating standards, devising regulatory framework and load forecasting, and much more. So ma'am will be chairing the themes on renewable and emerging technologies and trends, regulations for the evolving smart energy systems, smart city gas distribution, and smart water. With that, I would like to hand over the stage to Anjali ma'am for some opening remarks.
Good afternoon, everyone, and welcome to this technical session of presentation of papers on various topics highlighted by her. So, power quality, I think the first few papers are on power quality. Power quality has become very important with the introduction of renewables, with data centers, with all the electronics we are having in our systems. So, any issue highlighting power quality has become very important for us, impact of harmonics, and there are other things on city gas distribution systems, smart energy communications. So, we will go through the papers one by one. So, the first is paper I would like to call upon Mr. Manas Kundu on power quality monitoring and analysis for optimized quality power delivery. Oh, you are there. He's an old friend, so I would call upon him to. Yeah. Okay.
Shall we do that now?
Yeah, we can do that.
Okay. Yes, sir. So, yes. So, ma'am, we are starting with presentation number 26.
With presentation number 26, okay. Smart city gas distribution.
Yes, ma'am. So, Mr. Digambar Singh, Manager Sales Energy Division Process Automation from ABB India Limited is here. And the presentation is on digital technologies transforming the city gas distribution value chain from source to consumer.
Welcome, Mr. Digambar. Please go ahead with your presentation. You know, the technical presentations are the most important. You put in a lot of effort, all of you. So I welcome you all and request you to present your paper.
Good afternoon, everyone, respected panel, and thank you, Mr. Kundu, for giving me the first opportunity to present. So I'll be covering the topic of digital technologies transforming the city gas distribution value chain from source to consumer. So as we all know that there has been a lot on discussion of greenhouse emission, which is being done worldwide. India is the world's third largest emitter of greenhouse, and there has been discussions of reducing that, and India has committed towards its effort. India has committed to reduce its greenhouse emission by 30 to 35% of the GDP by 2023 with respect to the parameters which were there in 2005. So how we can do that? What are the different options that are available? So solution lies in terms of green energy. So there are various green energies that we have, one being LPG, which we have in our homes for cooking, and then another being natural gas, which is being predominantly focused and pushed by government of India. So India is also planning to increase natural gas to 15% in its energy basket by 2030. Also, there has been predictions from analysts that 70% of India's population will be covered by CGD. So how we are going to do that? For that, government is investing a lot in terms of infrastructure, in terms of easing the operations, because CGD has its own challenges. We are saying that CGD will solve the problem of greenhouse emission, but it's had its own challenges which can only be solved by digitalizing the network. There are different methods of digitalizing it because we have all the data available. We have to integrate it, we have to bring it to one place, and then we have to utilize it better. So digital solutions have different parameters. We have to integrate, like in any CGD network, if you see, there are domestic users, there are industrial users, there are your CNG stations for your buses, autos, and other vehicles. So we have to integrate all those locations, we have to digitally enable them, and then we have to put some analysis on that so that data can be better utilized. So what are the challenges that are faced by major CGD operators? One being distributed locations. If we see the CGD location by any operator may be distributed across city, even across state or even in country. Second is last mile connectivity. What we have seen, if we have not digitalized the CGD network, the consumer at the start will draw more gas and consumer in the end will not the gas. Flow and regulation control, so that proper gas distribution at each level can happen. Domestic users will need gas at different pressure and flow. Industrial users will need at different pressure and flow. And difference is there for your vehicles or CNG stations. Inventory and pilferage control. Knowing what amount of gas is available in the pipeline network is very important for the planning of buying of gas, distributing it to different locations, and also pilferage. The challenge, another important challenge is manpower. These jobs are manpower intensive as you have to go at each site, record the data, and then send it to the central location. Now the prices have become dynamic. So gas prices we need to change even day wise. For that, going at each of the location, at each of the CNG stations and changing the price of the dispenser is very difficult. Expanding operations. Most of the operators start with 10-20 location and then they keep on adding up to it. So what are the solutions that digital technologies proposes? One is building a strong backbone, by meaning that to install different measurement devices, to install different control devices in the field, where they have assets like their district regulating station, their metering regulating stations, their CNG stations, industrial consumers or domestic consumers. So at first they will install the meters to take the parameter. Second, now since the meters have installed, the control is required. For that there are different devices like metering skids, pressure regulating skids, and district regulating skids. Now once you have gathered all the data from the field, you have to bring it to one place and then send it to central location. For that we have something called as remote terminal unit, or sometimes it is also called as data concentrator. So having taken the data at one location, there are different communication media through which data can be sent. And in the central control room, we have something called a SCADA system, supervisory control and data acquisition system, which will gather all the data on real-time basis. It will show the complete representation of each and every asset. We can also do the price change sitting at a single location to your locations distributed across country through wireless or GPRS networks. Then also there are also business systems which generally these operators have. One is ERP. There are different ERP providers, one being SAP. Then there is GIS. You need to integrate your data with GIS system to have better visualization of data. Asset wise, also longitude and latitude is being put there. Moving forward, the case studies, I will cover Assam Gas Company Limited gas distribution to their tea states. So what was happening with this company? They were having a network across Upper Assam and they were not having any digital solution. They were distributing gas to tea states for burning their gas leaves and producing the tea what we have. So the consumer in the first was drawing more gas than what was being bought, and consumer in the last was not getting any type of gas. So what we did there, we installed a flow control valve near each of these industries along with remote terminal units, pressure and temperature transmitters, and then we centralized the data using a SCADA system. All this connectivity was done on wireless communication. Though that terrain is very difficult where we don't get any data from any of the major service provided, we integrated with their management and we provided a solution. So now what is happening, there is a predefined limit for each and every consumer. So SCADA system is being integrated with ERP system, through which we are getting to know that what amount of gas that particular consumer has to utilize. And if 100% of that being utilized, an SMS will go from SCADA system centrally that your gas amount has been utilized, you need to recharge. And if they are not recharging it by reaching some one point X, which is defined by end user, the gas supply will cut off automatically. There is no any manual intervention there. So now they are successfully running their operation. Initially they were running around 74 locations. Now they have expanded it to 400 locations. Another example is Thin Gas City Gas Distribution. They have their GAs across states. They have their GA in Punjab, UP, Madhya Pradesh. And they were one of the first customers which were coming up with requirement on cloud-based system. Now, many of the city gas distribution companies, if you see in the past, they were just gathering the data centrally in a SCADA system. They were not utilizing it. They were not doing proper planning. Thin Gas went one step ahead. Along with the SCADA system, they also asked for the predictive maintenance system, gas demand forecasting, and anomaly detection. So that in case they have in future, they know that their compressor or devices in the field is going to require some spare. They can predict in present stage for around 6 months or 1 year. Also, gas demand forecasting is very important for them because they have to plan how much gas they have to buy, how much gas they have to dispense. So with that, they can plan in future of about 6 months or 1 year. So what we did here, we provided our SCADA system on cloud. We integrated each of their CNG, CGS and other location in the field with RTU and GPRS communication. And then we are also integrating with other third-party systems like ERP, GIS, CCTV system, RFID system to have a centralized single system for catering to all these devices. And they are also successfully changing the price centrally sitting at their Noida office across 4 states which I mentioned. So what are the key takeaways or recommendations that we like to give? One is that definitely in terms of reducing our greenhouse emission, we have to go towards greener fuel, and CGD is one of those options which are predominantly being focused by government. Digital technologies can solve the problem what these operators are facing, and then adopting a strong and future-proof digital backbone, like what I mentioned in the field that we have to install pressure metering devices, your measurement devices, your RTUs, and then utilizing the benefit of Industry 4.0. Just getting the data will not solve the problem. This is solving the current problem, but we also have to see the future problems which will come. So for that, we also have to utilize the benefits of Industry 4.0. With this, I will end my presentation. Thank you, everyone. If anyone has any questions, they can ask.
Thank you.
Thank
You
you.
made a very good presentation. Any questions to him? I have one question that what is the communication you are using? RF mesh?
We are using GPRS, ma'am, because
GPRS, okay.
RF is not feasible in terms of those distributed locations.
Okay.
And data here is not that frequently required. If you see an operation of pipelines where you need regular data or upstream production, then there are different VSAT or OFC communication is being utilized.
Okay.
But here it's GPRS, 4G, 3G.
Okay. Thank you.
Thank you.
Thank you for your presentation. Very good insight into smart city gas distribution. I think now we can start with you.
Yes, ma'am.
So I invite Mr. Manas Kundu to give his presentation on power quality.
Just Mr. Manas Kundu is Advisor Energy Regulatory Affairs at ICA India and Coordinator Asia Power Quality Initiative. And the presentation is on power quality monitoring and analysis of optimized quality power delivery. So with that, I'll just load the presentation of Mr. Kundu.
Thank you, madam. Thank you, sir. Accidentally, you are here again, at least for an interesting subject which he has been always desiring to hear. And I thank Parul and team as well as ISGF to give me this opportunity on behalf of 3 paper writers. Madam Vandana Singhal, she is the Chief Engineer DPT in Central Electricity Authority. Then Rajan Mehta, he is the CEO for Efficient Energy Consulting, who does power quality and electrical safety analysis and study. And of course, myself, I look after the Asia Power Quality Initiative affairs in India. So this is a perfect example of collaboration. And in today's world, without collaboration and partnership, we don't do much progress. So with that, our presentation, the topic is PQ monitoring and analysis for optimized quality power delivery. The paper will be, of course, available to you, courtesy ISGF. You might have already seen it. I will take you through some basics, what we have done and why we need it. You heard throughout these 4 days probably the data, the IT, the intelligent, the smart. I also see that in the forum, many of the participants are just below 30, not like in our age group 60. We have spared ourselves already. And I think you all are the harbinger of the change which this country needs. So, this is PDF. This is open by PDF. So they have opened the PDF version. I told PDF it will not help me.
It is not moving, no, sir.
You open the PowerPoint version.
Okay. We had short of time, so I request all the presenters to make their presentation less than 10 minutes.
Oh yeah, no problem. That is what is flexibility all about.
Yeah.
You have to
So I
manage.
will request you all. I know it is.
Sure.
Everybody wants to speak and
So,
you would like to hear them at length, but we don't have time.
one second. One second. So, meanwhile, can you please go with this? I'll just set it my system
Okay, I have a small problem. I gave Parul both the PPT as well as PDF. PDF for circulation and PPT for use here. But unfortunately, she could load only the PDF version. I will go through the PDF version, but there will be a little bit of wastage of time. So my efficiency will go down here. I am definitely sure about this. Now the power distribution, we are the third largest power producer of electricity in the world today. And if you look at this pie chart, the electricity consumption by industrial and commercial sector is greater than 50%. We just heard about Industry 4. Also, we are seeing the digitization of our economy, what is happening. And as a raw material, when the power goes into it, it's a productive input. And if the quality of that productive input is not right, then we'll have a serious challenge to meet. And that is where I will come. The drivers behind the digital economy, if you see, and these are all familiar figures to you, we started Chalta Hai attitude earlier days. So varieties of standards all across installations. We have no respect for standards. Whereas we always look forward to the Japanese who are the world class. And if you work within Japanese, then you will see and understand what it is to adhere to the standards. Then we have started working on VSD, digital drive for all our industrial process to make it more efficient, more productive. Then we started metro for cleaner transportation across our cities. Then we see all our houses have started slowly changing from those conventional loads to completely power electronics driven load today. But as a common customer, we just simply don't understand. We also see the revolution which has taken place and started by India from GSL to CFL to leapfrog jump into the LED. And the kind of LED which has gone in initially and what has gone in today in terms of the technology of improvement, we have seen what kind of impact it can have on a grid total basis for reactive power. When I say the power quality, and if I ask you a question, most of you will immediately raise your hand and narrow it down to harmonics. It's not all. There are n number of dynamics into the power quality total framework, which we have to understand. So we expect a significant deterioration from the current levels of what power quality we have, and when we are transiting from old traditional system to a destructive way of power system. So unless we take that into consideration, we are in for a surprising shock. Now here what you see, the effects of power quality in industries and utilities. Utility and industry, when it comes to power quality, unfortunately in India, utility is starving for revenue generation. So they look at power quality as a tool to generate revenue. Morning I was hearing another thing, that demand response. I think our public utilities are excellent in managing the demand response by a fantastic tool which we discovered earlier called load shedding. Those were the days, but today things are changing. The same thing, if you look at all these loss of production, brand damage and many other things, it all are caused by poor power quality. And often the utilities are blamed for it. Now, common customers cannot blame. Obviously, the industrial customers blame the utility because they pay a highly remunerative tariff to the utility. So they have a voice not only before the utility management but also before the regulator, and they have the technical capability to prove what they are saying. Now, if you look at this, if utilities are to be blamed almost always, then a time has come that utility has to get into the power quality monitoring, because industries and bulk users, they use this very effectively to improve upon their performance and walking on a thin edge. We are really walking on a thin edge in terms of our grid today. Now look at that. When you do that, we call it an energy bug. Only we see the loss of brand, energy spikes, downtime, malfunctioning. In malfunctioning also, if you are somebody from the factory, your boss or your CEO or CFO will say, अरे तुम ठीक से ऑपरेशन मेंटेनेंस नहीं करता है, उसके लिए फेलियर हुआ. You go with a proposal to him with all measurement and all, sir power quality ठीक नहीं है, इसको ठीक करने के लिए ये करना चाहिए. You will be shut down then and there. You will say that you are not doing your work. My system should be always running and you should be producing. So that's the attitude towards power quality, because we have never try to evaluate the economic impact of poor power quality on our operation. That is where it comes. So when you have the tools, do you have the tools to navigate the evolving power quality landscape? And what you cannot measure cannot be managed. If you see, I have striked off that measure. What you cannot measure, cannot be managed, should be coming to today's paradigm. What you cannot analyze cannot be managed. We are putting 250 billion smart meters. Unfortunately, I sense that it will boil down only for revenue metering data purpose. We will keep aside the capability of those meters for demand response. We will keep aside for capability of the meters to give me the load forecasting capability with the climate change, what is around us, will keep aside many more multifaceted capability of those smart meters. And we are chasing a dream where 250 billion smart meter will put. Very recently, I was surveying in one of the state in Western region. RAPDRP put a lot of meters. Even the superintendent engineer does not know those meter data are not getting downloaded and analyzed. So that will be very unfortunate when we speak here and our tire does not hit the road and we don't get anything out of that data. It will be very unfortunate. Taxpayers' money will be going into that. So PQ standards, they are enablers for better PQ management. If I ask you, the last one, number 1, Forum of Regulator Model Regulations on Power Quality, how many of you are aware of? Probably very few will be knowing that. Then if I ask you IS 17036, whether you are aware of, we are having a national standard on distribution system supply voltage quality. I think except 2 of us, nobody else will know. And PQ measurement and monitoring methods, this again, we are not aware of. And that standard is very soon going to come. Probably you will be seeing in under 2 months. So that is what we want to focus on. Now, how all this came in? I quickly take you, I had actually 2 case studies, but for want of time, I think one case study quickly I would take you through. This is a food and beverage industry in eastern parts of the country. It's a bottling plant basically with 2,500 bottle capping per minute. Just imagine. And they have a machine called Chrome and few other machines, very sophisticated. And they were having enormous problem. Annual monetary loss when we evaluated, 62 million rupees annual loss for loss of productivity, loss of inventory, loss of cards, and loss of brand reputation. So they were thinking that they will get out of the state because the state utility at that point of time, they were thinking that they have given the supply and that is enough. We have given you the supply. They never bothered about the quality of the supply and the impact it can have on the livelihood of all those people who are working in the factory. So unplanned interruptions and all this. Now it was further aggravated because it was supplied from a 220 by 33 kV substation and 33 kV bus was having a traction line, traction feeder. So it was aggravated by that traction feeder. Now so this is a single line diagram in a very simplified manner. So they were using a lot of DG sets and power quality monitoring. When we started doing there, you look at all those violet points, there are varieties of points, locations, not only the PCC, the control center, what we consider for IEEE 519 references. And once we did all those measurements, these are the kinds of data which were thrown. And almost for a month and a half, this was done. Now it was possible only because it was a multinational. And they were always looking at sustainability. And they were always looking at the energy efficiency as a highest point in their operation. So they allowed to do this kind of audit. Now, if you see, the maximum voltage is 34 kV, 34.2, the minimum is 24.7. If I compare it with standard, it's a non-compliant, right? So there is an action which has to be taken. Similarly, under voltage events and over voltage events, if you see, you all have heard of ITIC, Industrial Information Technology Industry Council curve, ITIC curve. So on all the events, the incidents, what you are seeing, beyond those curve bandwidth, they are not suitable for all the information technology equipments which is deployed in that factory. So we are seeing here that there is something has to be done. And what they did, basically they did a servo control voltage stabilizer, which was not supposed to manage this kind of events, which is rapidly happening, which can manage only little bit of voltage regulation. Okay, you understand, if you are electrical, you will definitely understand that. Then if you see 3.15 MVA transformer events, again with ITIC card, there are a number of over voltage, under voltage events, including the power cuts and interruptions. So these were the different things which got analyzed after we captured those data. Now what are the results and the recommendation? The first recommendation was install 2 UPS, because those equipments which they were using for bottling are very high speed, and if they were not giving a very steady voltage, every time the equipment worth crores of rupees was getting some component damaged or other, and downtime resultant. So 2 UPS of 600 kVA which are put in critical location for chrome lines. Then DISCOM needs to separate the traction feeder from all industrial feeders. So there was a lot of debate. It went from regulatory commission to the distribution company. Finally, the energy ministry, when they stepped in, this segregation was done. Then third, protection settings should be adjusted so that undue tripping does not happen, which was happening earlier, and further investigation required for 2 millisecond voltage dips. Then SBC, I talk about static voltage controller with load balancing control, can balance out the voltage supply, and auto changeover of supply through RMU find by 2 reliable HV feeders. So these all were implemented, the jobs were saved, and annual loss of 62 million were saved by way of power quality data measurement, collection and analysis. So before PQ monitoring analysis, after PQ monitoring analysis, you can see this. I don't want to take you through that. I had a data center, but I don't think I should take you through the data center detail. The data center, in summary, I will tell you, 50 megawatt power hungry data center, they applied for a connection. It's in Western India, and the utility approved that connection from a grid where already a steel plant which is operating on 220 kV bus. Now data center operation is extremely sensitive. If you have any kind of power quality events, and if it gets stripped, then our Amazon, our Facebook, many things will not function if they are catering to those requirements. They have alternates, they have enough flexibility, so they are able to. After detailed analysis, it was decided that with those analysis results, they can get a prior intimation that what precautionary measure they have to take to keep the data center up and running. And management took a decision by requesting the distribution company to segregate us from that steel feeder, give us a separate parallel feeder from 400 by 220 kV substation, so that we get the 50 megawatt, because they have a huge plan. In one data center, the total requirement is 1.2 megawatt. So it's the kind of thing, and compliance with, because data centers are always complied with semi standard. So power quality management, the power quality measurement, monitoring, analysis, it's really a torch in the darkness. It can show you that what you can measure, what you can collate, what you can analyze, what you can improve, and what you can control. So these are the things which you can do. With that, I come to my last conclusive slide. And as I started in the beginning, PQ monitoring and analysis is equivalent to the revenue. And it must go not only in Tata Power's head and BSE's head, it has to go in all our state discoms head. A time has come. I think we all have been trying. They don't see the reason. They look at only the revenue, how to penalize the customer and get the bill. We talk about customer-centric approach. Customer for us, even today, at many places, customer is customer. Customer is no more God. Gandhiji's principle is God. So we must do something around it, and that's why I said, I exhorted the younger people can make that change. Okay? The PQ analytics, we have tremendous amount of data, and that data is going to come like tsunami for us. It can help us in our asset management. Unfortunately, our human resource capability is not geared up to do that analytics and give us that kind of insights today. In public utilities domain, some of the private utility already started and taking help of AI and all that. I think going forward we will see good thing. The smart meters without PQ will be the opportunity lost for ourselves. And adherence to standards is going to give us the reliable, efficient and sustainable grid for which we all are working for. Thank you for your time. And
Thank you.
Sorry, I crossed my time limit.
Thank you for a quick insight into power quality and exhorting all of us to look into power quality. We'll now go in, we have a change in the sequence. We will go in for smart water papers from Abu Dhabi distribution company. Innovative smart water metering in a multi-utility environment by Mr. Rashid Mohammed Al Mazruli. I hope I have pronounced it right. So please present your paper from Abu Dhabi.
Mr. Rashid, can you hear us, sir?
Yes, sir.
Yeah, please.
Good afternoon.
Good afternoon.
You can start and please limit your presentation to 10 minutes. We would be very grateful if you give us the main points in 10 minutes.
Okay, let me share my presentation first.
Can you make it full screen, please?
Is it okay now? You can't see my screen?
No, sir. It's not in the full screen mode
It
yet.
would be better if it is in full screen.
Check now. Now it's okay?
Yeah, you can proceed with it. I think people can see it. So please proceed.
So now we can see my presentation?
Yes, we can.
Yes, we can, sir.
Okay, thank you. First, thanks to all for inviting us to participate in this India Summit, Smart Utility. I am Rashid Mazrui, I'm engineer from ADDC Distribution Company. I am heading the Smart Metering Management Department in Abu Dhabi Distribution Company. Today we are participating with an innovative smart water metering in multi-utility environments, and we'll go into details during the presentation. So let me introduce first our company. Abu Dhabi Distribution Company, one of the national electricity and water distribution company in Emirates of Abu Dhabi, located in the United Arab Emirates. We are the sole distributor of the water and electricity among the Emirates. Also, as ADDC managing both electricity and water, we have a kind of complex metering landscape where we having more than 70 electricity and water meter models with different type of protocols such as DLMS, MBus, Euridis, Modbus, and we have the very old one which called 7 trends for the water meters. For this deployment, for sure, we have a different kind of premises. We have, for example, villas, buildings, shops, stores. So we have a different kind of configuration, we call it. So we have one-to-one relation, we have one-to-two, we have one-to-many, and we have recently point-to-points. Our focus today will be to the point-to-points meters, which enable us to connect to the water electricity meter. And this is let's say, the majority or the significant number from the kind of communication that we have it for the meters. Point-to-point, it's kind of communication modules that get the readings from the electricity meter and sending to our heading system. With electricity and water meter models, we have a different, for sure, we need a meter profile, we need a meter register, working over multiple kind of protocols, the hidden system solution, and also to have a power near to the water meters, which is already difficult in our scenario. So we came with this innovative idea that helping us to enable remote connection of the water meters and meanwhile also the electricity meters. We came with the 3 different options that allow us to solve this issue or this challenge in order to smooth the operation. Either to use a separate gateway for the electricity and water meter by providing an AC power source for the water gateways, which already a challenge in most of the scenarios. Option 2, we consider a cellular communication modules for the water meters. We call it point-to-points, but there are no power incentives, nature, and drain the meter battery. Option 3, which we see it is more visible and more economic, that we connect electricity meter to the water meter using MBus cables. Hence, we are able to connect the electricity meter, meanwhile also the water meter. The objectives of this initiative idea that I reduce the OPEX in terms that I am sending the meter reader to the site to bring to visit the site to collect the read. Also, we are increasing the accuracy of the billing by enhancing the remote connecting of the water and electricity meter. And for sure, this all related to the customer delight that he will able to get the bills in correct reading and also in the frequency that he need from this one. In addition to that, we are able to identify the customer with a daily reads in case that he have a leakage in his premise, so we'll be more proactive in terms of the use cases within this environment. Now, if we talk about the solution architecture, so here if you see in the left-hand side, we have the water meter connected through the MBus cable to the electricity meter, and we use the cellular communication GPRS and that connected to the header system. So how the solution changes? And we have 3 steps, procurement due to upgrade to the meter design. So we'll have MBus port included in the electricity meter specification, which already we ask ahead from the meter manufacturer to have RS485. We have electricity meter firmware has been additional for register of the water meter. So we have a bottle, so we can trigger the battery life, total volume, max flow, and error status. So we're able to collect more than only the reading. We have also the profiles of the water meter. In the hidden system, we are pulling, we have a pull request, so the electricity meter would append the water meter register. So this is the first step. The second step, we go to reconfiguring the HIS. HIS, it means the hidden system of the meter. So a meter datagram was upgraded with additional load. So HIS data capturing the schedule and data processing was updated. The final stage about site installation and the process. So redraft the field installation process and tell that, okay, when he installed the meter, he will able to connect the M-bus cable. So it will be a matter of configuration of the hidden system and which able to send the reading to the billing system. We are using Oracle billing system. In addition to that, for sure, for continuous improvement and to keep the team or technician up to date, we provide a training to the operation maintenance team to troubleshoot the issue if there is any issue related to that one. And if there is any complaint from customer, they are able to solve it in the fast manner. Here, if you see in these pictures, it's a real photos from the site showing to you how we connect this one. If you see in the left-hand side, this is the electricity meter. If you see the Modbus port that we are connecting the cable, and in the right-hand side we have the M-bus water meter that are located in the same premise. And this photo from the field itself. So, and this is show to you how is the hidden system. We call the HIS, if you see the left-hand side, if you see the information that we show to you, the battery life, the error status, the max flow, the total volume. This helps us to get the information from the meter. In the middle, you have the cumulative volume from the water meter as well from the hidden system. In the right-hand side, in the corner, you see the cumulative active energy that's important from electricity meter. So by doing this one, we'll have the information for the meter. We are able also to be more proactive with the customer. We notify him in case that his consumption water meter reading has been increased suddenly with more than 300%. So we notify him in case of the leakage. Meanwhile, we are getting the active energy reading and also the register of the electricity. So the key takeaways and the conclusion from this one, for sure, maybe I mentioned in the beginning about the objectives of this study. It was a start with the point-to-point electricity meter. After that, with the internal study with our specialists from the metering department. Also here I want to thank Engineer Ham. He was part of that team that involved in this innovative idea. So the benefits of this multiple utility metering using will reduce the capex as additional water meter gateways no more needed. Also we reduce the cost of the operation maintenance as we call it the OPEX, that we have less complex. We reduce the load in the telecommunication network as a second telecommunication channel. So instead of buying 2 SIM cards and 2 solutions, we are doing only one in the same premise. For sure, the scalability of the solution with the moderated change. The way forward, we are doing now in the large scale. So after we think about, okay, now we are a part of the Modbus, there's another technology we are using, the RF mesh. Now this we are testing this solution. Apart from also the 4 water meter, register meter firmware and meter memory can be updated to having more than to have more information for the electricity meter register. This is what we participate as a paper from our company as ABDC. So this solution, final statement or final to keep the story short. So this solution achieved the energized and smart metering performance. For sure, people now they are looking to more than behind the meters, not only the solution. And we look about the quality-oriented manner that we are more than we are meeting with the customer expectation to have innovative ideas, and we enhance our protocols and telecommunication technology. Thank you for all.
Thank you, Mr. Rashid, for a very meaningful presentation on how to combine water and electricity in a metering in a multi-utility environment. Thank you so much. And now we'll move to the next presentation. Yeah, in-house robotic process automation by Mr. Harshraj from Noida Power Company.
So thank you so much, Mr. Rashid, for the detailed presentation, and hope you stay back for other presentations as well. But we are moving ahead now with our next presentation, which is on in-house robotic process automation (RPA) by Mr. Harshraj, Senior Executive IT, Noida Power Company Limited.
Okay, thanks, Doc.
Please go.
Good afternoon, everyone. I would like to thank ISGF for giving me the opportunity to present my presentation. First of all, I would like to tell my name. My name is Harsh Raj. I came from Noida Power Company Limited. Noida Power Company Limited is a joint venture with RP Sanjeev Goenka Group and Greater Noida Authority. We have a license area at Greater Noida. First of all, I would like to tell what exactly in-house robotic process automation is. In-house robotic process automation is Python-based GUI-based scripting tool bot that we have used developed for automating SAP-related processes. It also has the analytic dashboard to monitor the processes. What exactly in-house robotic process automation will help in? Reducing process time, reducing human errors, improve productivity, and save man hours. Before I start, I would like to tell how we have derived to robotic process automation. As you can see, this is the use cases. Here you can see a person need to come to office, open his SAP, and run some P code and downloads the file and find out the eligible cases. And also he need to send some of the cases where some charges are there. He need to some concerned department. So you can see for running one case, he need to around 10 to 15 minutes. If he run 6 to 7 cases, he will be required around an hour to execute the process. So we have taken this type of process as it is very repetitive in nature, time consuming, and from where we can save some man hours. So we were thinking to opt something which could save our man hours. Based on the mission of our company, that is innovative and use and to improve our business process with best available technology, which will provide an error-free services to our customer. So earlier we were thinking to outsource this project, but somehow we started with my team members, so thought we will be taking this as an opportunity and we will be doing this completely in-house. So we have team. As you can see in the development phase, earlier it was a human, we have replaced it with a bot, and we have used some technology that is Python, and we have used Oracle as our database. And also I would like to tell this in-house project is completely based on our open source platform. We haven't used any paid platform for this, and we have also done a vulnerability audits for this so that our process in our bot is not vulnerable to our organization. I would like to show you a small video of the implementation that has been done. As you can see, it is automatically being run.
Oracle is the database only.
That's why we have a large IT team, and we have the potential of the information and data. So as a backend, we are using SAP right now, but Oracle giving the platform for integrations right now. So that's why in our robotic process we use this as an integration process. So for the integration we check other options also, but find that the Oracle is best for suitable in this sector. That's why we use.
As you can see, this is the architecture of the bot. This bot is also of two types of nature. One is schedule bot and one is the click bot. I have shown you the example of the click bot, but in the schedule bot, we have also done a project which is MR Note 10, where the user kept a file at particular location, 8 o'clock in the 8 o'clock in the morning. The bot automatically picked that file from that location and update all the MR notes which need to be updated in the SAP. And this is the use case of the schedule bot that we have done. I would also like to show you the use case of the clickbot. As you can see, we have used an exe file. One thing also we also do domain type authentication, so that if some other people wants to run this process, will unable to run this process, as we do the matching at our server and also at the system and domain base also systems, and we find it eligible cases. And also you can see we send the cases which need some concern, we also send to a concerned department after running the bot. The major key takeaways of the improved service delivery. Earlier it was taking around an hour to do 6 to 7 cases. Now it is within a minute the bot automatically run the process completely. It is an error-free service, that is the process is done by bot. Reduction in the cost COPQ, as the person who was doing this process, now we can utilize that person to do the other process, so that we can improve our service deliveries. Automation of the process. Now we are working on 2 or more process, that is LCC court case preparation and category conversion. Before 31st of March we will be going live with that also, and team morale is very high. I also have with me my team member Mushahid and Diksha, who were actively part of in this project with me. Thank you.
So you've heard a very illuminating presentation on how to automate your processes, but I hope you will not take away jobs from people. Yeah.
Well said, ma'am. I want to just add one more thing. That's in last year we just targeted one more things in our organization, that is the zero defects. So we are going to be just implement all these things where the elimination of the defects can be done. And during this process we found the commercial activities and operation activities have some defects due to the man interventions, and due to the robotic process now it is has been eliminated. And right now our target was just to reduce it is to 30 to 40%. Now it is almost 80 to 90% has been reduced. So it is well said. And we also curbed our SLA due to this process, as well said by us. It takes the time right earlier, but it is just in minutes or in 1 hour it has been processed and going to be concerned departments. So we reduce our SLAs as per UPRC norms. It is very important for us to close any complaints and anything which is received. So it is very useful for us right now, and that's why going to be just parallel implementation for other process for other departments, commercial, recoveries, and legal department also. Thank you.
Thank you so much, Harsh, for the presentation. We'll be moving forward with our next speaker, Ms. Purnima M. Gupta, former Economic Advisor, Central Electricity Authority. Welcome, ma'am. And the presentation is on smart energy communities. I'll just quickly share the presentation.
I've personally known Madam Purnima for a long time, and I welcome her for this.
Good to see you after so many years, I think.
Yeah.
Last COVID आ गया बीच में.
I was in Punjab.
You were in Punjab.
Remember Punjab state.
You have the scene.
Yes.
Okay, fine.
So you will move the.
I'll do it.
You move. Good afternoon, everybody. Am I audible?
Yeah, please.
Okay. Good afternoon. I am grateful to ISGF for giving me an opportunity to speak about a topic which is seems to be quite different from the usual, the electricity dominated presentations. Of course, my work at Central Electricity was also on electricity and the reforms. We were working for the reforms and monitoring of the various initiatives taken by the Department of Power. However, this is on a slightly different plane. The domain here is people. People, not necessarily engineers in the department, but as citizens of a country, communities. Communities are made up of ordinary people. And obviously there are a lot of organizations as well. So I want to look at the role of communities for helping us to manage the electricity, manage the energy issues, because we are all facing a lot of challenges, as you know. All of you are aware about the problems. We know that the conventional sources of energy are fast depleting. These fossils, they are not renewables. Most nations have moved towards greater use of renewables, and India is also committed to expanding its renewable energy use by 500 gigawatts, 2030. This is a very big challenge. We know that. So how are we going to tackle this? Or how are we thinking of, going about looking at this huge challenge facing us? So what I suggest here is that behavioral changes across communities are needed. And that can be one of the ways to meet this huge challenge. We know this challenge has come to us from the global level, and it has percolated to all nations through the United Nations Sustainable Development Goals. We are well aware of that. And India has translated it in these terms, and our governments and other stakeholders are also trying to understand how to meet it. So I suggest, as a citizen of this nation, that smart energy communities are built through initiatives from micro level and stringent directives from the top. It is worth making an effort. So this is one way of looking at arriving at some kind of a approach to deal with this very big challenge of renewable energy, which we know is a must. We have to do something about it. It is acknowledged across communities that renewable energy use is sustainable and it is cleaner than use of conventional fuels. Smart energy communities are built through initiatives from the micro level. Micro level will mean at the household level, at the level of an enterprise, a firm, manufacturing anything, then at the level of an official department, at the very basic level. It could be the village level, it could be the district level, or any level, across different levels. So you have to have some kind of a thread which weaves together the different aspects of the community. Energy conservation, energy efficiency, and transition to net zero carbon emissions are the pillars to move along the path of clean energy. So we have to look at the issues in this manner. I have taken the case study of India International Center. Can you move the slide, please? Pardon? We have taken the case, the next one please. We have taken the case of India International Center at New Delhi. Most of you may have been there or at least heard something about it. It's a very important center right in Lodi Gardens, just next to the gardens, and most of us frequent it, for entertainment or for even for residential purposes. So IIC took the initiative of undertaking energy audits from 2019, and this has resulted in saving of energy to the extent of 1.6 lakh units of energy per year. So what I'm trying to say is, communities means different organizations, So if they come together, they can help a lot in saving energy. Because what we have to do is, we have to do energy efficiency, energy conservation, and net zero. These are the objectives before us. How has IIC done it? IIC has taken several important measures, actually implemented. from 2019. Zero discharge of untreated solid and liquid waste. Doing away with dependence on underground water by using recycled water. Upgrading its buildings to green standards. Best green practices and outcomes and savings in costs. As we know that when you go for green practices, there is an economic benefit. A very big saving in costs also results by taking up green measures. Similarly, replacing lights with LEDs. We know that we have LED bulbs at home. Our energy consumption is less, though they may be a little more expensive, but then with time they are going to get a little cheaper. Rainwater harvesting, use of biourja, and the energy system is also monitored through SCADA. So undertaking various measures and monitoring them periodically is going to take us forward. It has already achieved significant savings, as I said, 1.6 lakh units per annum, which is a very big amount. So if you ever happen to go there, you can look at the system because a lot of it is open also to public. You know, you can go and see it for yourself. It's all in public domain. And one can pick up some points for the organization that you are working for or that you are interested, to improve in terms of energy efficiency. Then Professor C.R. Babu, he is from the Delhi University. He's a fairly old person, but he is actively involved with this system of environmental improvements of the JNU area. In the neighborhood of Jawaharlal Nehru University, he has constructed a wetland system. He has actually done that. And how does it work? He has used plants. These plants, they take all the pollutants from the water is treated, and then it flows into a natural depression, which is a lake. And there in the lake, you have ducks, you have beautiful plants, and you have a small garden. So it becomes like a tourist resort. Because I went there personally and I had to look at the whole thing. So please go ahead and see that also. Professor Babu is involved in many ways in various departments of the government. He's a fairly old person, but his experience has brought rich dividends for the cause of environment in Delhi and perhaps outside Delhi also. And this particular place is really worth a visit. It's beautiful, just next to GNU. Then we also have the Manohar Parrikar Institute of Defence Studies in Shankar Vihar near Cantonment area. They have also given their untreated water to a sewage treatment plant where it is cleaned, and that water is used for gardening. This is actually happening, and the STP works for many other organizations. This is just one example I'm giving. And then in our own society where I'm residing now, a resident welfare association has undertaken, with the help of a power utility, rooftop solar. And that has given us a saving of 45 lakhs per annum. 45 lakh rupees per annum of saving in energy cost. All the benefit goes to the RWA, and about 500 to 1,000 for every residence. For every home in that society, we are also saving to that extent. So it's a win-win situation. We are saving on energy cost, we are cleaning up, and we are feeding the grid, with additional energy points. So these are very brief examples just to bring out that when there is a will, there is a way. And the will is there to improve, the energy scenario, to improve the environment. And how has it been done? So I have basically brought out to you, it's a grid of stakeholders across communities. They could be regulators, they could be RWAs, they could be academic institutes, they could be individuals like Professor C.R. Babu, who is doing a wonderful job. And we all get together and we look at solutions. First you have to look at the problem and then you find solutions. And it is being done. It is being done. So how do we go about it? I've given some measures which IIC has taken. But within households also, we can improve through demand side management. We did look at, in one of the earlier presentations, we have had a look at the demand side of electricity, energy use. So the recommendations that I'm trying to put forward, one is that you bring a group of stakeholders, a grid of stakeholders. There's an electricity grid, and that is combined with a grid of stakeholders. Let them come together and look at the different issues. And already a pilot program for behavioral changes, to improve the situation at the ground level has been undertaken in Delhi in 2019. This study is very much there, and that has further helped in reducing the demand. And when you reduce the demand, you have more energy available. So on the one hand, you are saving on cost, on the other, you are adding to the supply. So again, it's a win-win situation. But it needs demand-side management. The household energy reports, HERs as they are called, the household energy reports have to work towards that. So individual households have to work towards this objective. I certainly feel that we have to say, and I'm sure most of you are also along similar lines, but an average household, they have to be motivated. And that can be done. It's not that difficult. Similarly, at the societal level, if individuals, large number of individuals, they do this, then at a societal level also, you can mold behavior. Now we are already segregating, हम गीला कूड़ा और सूखा कूड़ा अलग कर रहे हैं घरों में, आपको मालूम है। इससे हमें दिल्ली सरकार ने भी दिए हैं और भारत सरकार की तरफ से भी और काफ़ी निर्देश आए हैं। वी आर डूइंग इट, हमें अलग डिब्बे मिले हैं, फ्री में मिले हैं, सरकार ने दिए हैं। बट हाउ मेनी पीपल आर एक्चुअली डूइंग इट? हाउ मेनी हाउसहोल्ड, इफ यू गो टू अ हाउस, if you just take at random, how many people are actually putting it separately and giving it also into separate bundles for the containers, which are taken away by the van which comes in the morning? Sometimes it's not being done. So this needs a lot of motivation, extreme, So motivated people, if they come forward, I'm sure we can take it. I have been doing it for many years, and I'm quite convinced that we should do it. It will help the bigger cause of the society to save on energy. Now, what about if we look at the grid security and the energy transition? Because net zero is what everybody is talking about. Technology is going to play a very important role, and blockchain technologies appropriately used are going to help us towards grid security and energy transition. You are well aware of it. You are all technical people. You know more than I do. So you don't need further. Similarly, prepaid metering, that also helps the cause. If you're पहले ही आप पैसे दे देंगे, obviously it's going to help the generator and the distribution company, both. So there, to improve the tracking and to improve the data assets, etc., what is going to be used? It is again the Bitcoin technologies. So I'm sure our systems are starting to use it, but it has to be on a larger scale because it's just the beginning of the whole thing. And lastly, the most important, we must pay for energy use. जब आपको कोई भी चीज़ फ्री मिलती है तो आप उसका मिसयूज करते हैं, हमें सबको मालूम है, ह्यूमन नेचर इज लाइक दैट। वी हैव टू पे फॉर द एनर्जी यूज्ड, and that is to be a principle. Polluter has to pay for his pollution. Energy user must also pay for the energy used. That is only the way to take forward more efficient use of energy, energy saving, and the cause of environmental conservation. That's it. You know the story, so I don't have to reiterate it. Thank you very much for listening. I hope I said something quite meaningful in this.
Yeah, thank you, ma'am, for nudging our conscience to act as smart energy community. So I hope all of us in our room in this room will look into ma'am's advice and conserve energy and help other people to conserve energy. Thank you. Thank you, ma'am.
I made it very brief. Any questions or any further ideas you want to give associated? This is basically people-centric, you know. We have to get the people, motivate the people. And organizations obviously will have to be the foundational blocks, so to say. Organizations across the communities. But it is the people, you know, who have to come forward with people who are aware about the problem. They have to come forward and join hands and work towards this.
Thank you.
Smart energy use. Okay.
Thank you.
Thank you, Nandi. Thank you. Thank you.
Thank you so much, ma'am. It was really great to hear from you with such an experience. Would like to invite Ms. Harsha V. Rao, Program Associate, CEEW, and the presentation is on regulations to enhance distribution level flexibility for renewable energy integration. Ms. Harsha, please.
Good afternoon, everyone. Thank you, ISJ, for this opportunity. I'll just introduce myself. I work as a program associate in Council for Energy, Environment and Water. It's a non-profit based think tank based in Delhi. I research on power sector regulation and advancing regulatory reforms towards the energy transition. Today we'll be discussing whether the regulatory frameworks for calculating the revenues and expenditure of DISCOMs need to be relooked in light of the emerging power market transitions. Basically, I think during the course of the day, we repeatedly asked the question that, there's so many smart meters are deployed, why are we not using the data? Why there's so many technical solutions have been provided on, automating, on communication systems, etc., etc. But then, and again, we're asking the question, there's so many benefits to it, then why are DISCOMs not actually adopting them? So today I'm taking a stab at answering this question by saying that there is something fundamental in the regulatory structure of the DISCOMs which kind of disincentivize them from undertaking these operations. So I mean, I'll move through these slides very quickly because I think we're very familiar with how the power system of the future will look in the future, what transformations are happening in the retail market because of variability in demand, variability in supply, and of course technical solutions to manage that variability, which are offered by distributed demand response and battery storage, right? So all of us, I think, fairly familiar with it, and that there's so many elements of the retail market have to shift to actually for us to leverage those solutions. So we have to, DISCOMs, the role of the DISCOMs have to change. They can't remain network operators that they've remained so far. They have to actually actively manage the network. Consumers are not passive consumers anymore. They're actually supplying to the grid, their capability of demand response, etc. New players will probably need to be there, like aggregators, like P2P providers. So all of that we're fairly familiar with, right? So today we'll just talk about the incentives of how do we leverage these technology advancements. So, and my argument here is that the business model of the DISCOM will also need to shift, right? So there are currently tariff regulations which dictate what revenue the DISCOM can spend and how can it what expenditure the DISCOM can make and how does it recover its revenue from the consumers. So I argue that the tariff regulations are not aligned with how we think the DISCOM will need to look in the future. So just delving into this a little bit, right? So the three foundational principles of a current tariff regulatory structure, which is that A, the DISCOM obtains its return on its rate base. There's something called the rate base. Second, that the DISCOM recovers the aggregate, that is the entire expenditure of its allowed expenses from all its consumers. It's basically expenditure divided by number of consumers. And the third, the revenue from sale of electricity, which is the tariff, is the primary source of its income. Right? So we'll tackle each of these three and understand that what is basically the problem. So the DISCOM obtains its rate on its rate base. Now the rate base of the DISCOM is at the capitalized expenditure, which is financed by debt, equity, etc. Now what is this capitalized expenditure? Expenditure which is and this capitalized expenditure typically includes capital expenditure, which is spent on things like building your distribution infrastructure, right? So something like maybe buying Python for automation is probably will not go into your capital expenditure, right? Which will not go into your a capitalized expenditure. Now, why is this a problem? It's a problem because the DISCOM obtains its profit, like there's a profit margin which is a normative profit margin, say 15 to 20% on its rate base. And if certain expenses are not allowed to be included in that rate base, the DISCOMs are not going to be making a profit out of it. So obviously there are certain expenditures it is not incentivized to make. It will obviously make those expenditures which it will make a profit on, because that's how the regulations are structured. So that's the first problem. I argue that the first problem why the certain, and we all know that system operations are more OPEX heavy, they're not CAPEX heavy, right? So the system operational type expenses which involve there was a presentation on there was a theme on customer engagement, etc., etc. All those expenses, they will not go into the capital side of expenses, and the DISCOMs are not going to make it. So that's the first point. The second is the certain technological advancements actually defer capital expenditure. So for example, if you have distributed renewable in the system, distributed RE in the system, there have been studies which show that actually they have the potential to defer certain capital expenses, right? So again, DISCOM is not incentivized to make those expenses. The third is that, right, again I think this point I covered, that the envisaged roles of the DISCOM actually expand its O&M operations. So this is like the three main problems with the point one, that the DISCOM obtains its return on its rate base. So this foundational principle we need to take a relook on that. Coming to the second point, that the DISCOM recovers the aggregate of all its expenses from all its consumers. I think this is a point we're all fairly familiar with. We're all familiar with the concept of utility death spiral and what will happen if consumers start leaving the DISCOM fold because of open access, etc., etc. So obviously this is again a very foundational problem, that you're recovering all of your expenditure just like all of your expenditure on the tariff wala principle, like per kilowatt, this will be the tariff you're recovering. So that's the second problem that we need to tackle. The last is that the revenue from sale of electricity is the primary source of income for the DISCOM. The second and third point are obviously linked, and obviously there are certain like we know that open access charges, wheeling charges, banking charges, all of them are departure from this principle, because they're allowed to levy those charges based on certain targeted expenses, right? But the problem is that practically what has been happening is that while they're allowed to recover those expenses, the DISCOMs don't calculate them enough. So there have been repeatedly this across in Haryana, in Chennai, in Gujarat. There have been many cases, and Maharashtra recently on the grid support charges, many cases where the consumers, especially the open access consumers, come back and say, tell me how are you calculating these banking charges you've imposed on us? How are you calculating these grid support charges? And frankly, the DISCOMs don't have the means to calculate those charges adequately, because right now there is no functional separation between their supply business and the wires business, right? So the DISCOMs actually then they don't, the argument really falls flat in the face. Again and again, the APTEL has said, the High Court has said that, has directed the DISCOMs to go back and levy these charges based on certain rigorous calculations, but that simple exercise we've not been able to make it happen. So these are the major challenges with the current regulatory regime. So then how do you fix it? So right, so how do you fix it? I would say that sorry, one second. Right, so I think the first point we already kind of hinted at before, that we need to have a functional separation of wires and supply. And again, this is like people come again and again keep on saying that we need to segregate the wires business, the supply business. We need to have completely two different entities. But I think I would start with something much smaller and say just separate your account books in the first place. Like that's a smaller thing to do, smaller thing, like more easily achievable, right? Instead of saying just create a new entity, just say okay, just start with separating your accounts. Even eventually, if you're moving towards creating these new entities, even any merger acquisition transaction which will probably it'll involve separating those entities, you'll need to have clean account books. So I think the functional separation of wires and supply business needs to happen. This has happened in some states, already started to happen. Some states do, when they come up with the tariff orders, they do have, even I think Delhi has, they do have, they calculate their wheeling charges separately, open access charges separately. So that's actually the beginning of functional separation of wires and supply. while some states, like I think it's Madhya Pradesh, which just randomly allocates some expenses to buyers and some expenses to supply. So these are things that you need to work on. We need to work on. The second suggestion I would do is that a fixed cost recovery through fees and charges. Now, instead of what do you mean by fees and charges? Like we already have those, we already have these wheeling charges, banking charges. Similarly, we start this concept of that people pay for what they're using. Right, some people, like going forward when DISCOM's operations expand, now if they're actively managing the network, not everyone is using the DISCOM as a source of electricity. Some are using just to manage their network, some are using for backup supply, some are just using their infrastructure. So the usage of the customers are going to massively change over the time. Right? So for example, even if a person has a distributed solar system and there's an aggregator in the end, maybe they're not using the DISCOM for their energy, they're using just for balancing, right? So then the DISCOM calculates, okay, how much does it take for me to balance that energy, and then charge the customer accordingly. So along with, they're not charging for tariff, the electricity tariff, they're also charging them for the services that the DISCOM is providing. So that's one element of it. The other thing is valuing services. Now, what does valuing service mean? We all, I think this, especially in relation to distributed renewable energy, we all are familiar with the concept of net metering, gross metering. There's so many discussions, challenges, back and forth around it. But like research by CW and other organizations, we've come up with these frameworks of calculating the value of grid-connected systems. And if you actually calculate, we include costs and benefits like cost of deferred expenditure, savings from deferred expenditure, savings of power purchase, actually cost of management, all of these things. So we value the service because electricity, while it's a commodity, in different points in time, its value is different. So accordingly, we value it and accordingly price them. So the pricing will change from just a tariff sort of pricing to a different sort of pricing where we calculate these costs and benefits of each asset, we can call it, and then accordingly value them. Function separation covered, and I think we'll come to the policy direction in a bit. So, right, so how do you do this? So policy direction needs to, of course, come at the highest level. The tariff policy, which kind of sets these regulatory principles, we need to take a relook. We need to incorporate these principles in the resource adequacy guidelines. We need to revise system operations. Then we, of course, need to build DISCOM regulatory and DISCOM capacity to start these changes. One of the major considerations, however, can be then, these are two questions we need to think more about. Then if you the DISCOM operations have now started to constrict, like they started to become smaller. We're talking about separation of wires business, we're talking about customers moving away from them. So the DISCOM operations are now becoming smaller, they're segregated, and if we're talking about recovering them meeting their expenditure through fees and charges, we're not talking about them making a profit, right? So these are all the operational and organizational kind of real political economic, you can say, problems that we need to then discuss a bit about. So system operations typically all over the world is something which is considered to be revenue neutral. So one thing that we can think about is that, when we're talking about system operation, customer facing kind of system operation kinds of roles, then then DISCOMs recover through fees and charges. There's no profit component involved. But when it comes to a more of supply business kind of component, then there's a profit element involved. So these are the sorts of things that we start the regulators to then frame the regulations accordingly. So so these were my few thoughts, and I would be happy to get any questions. And this is completely this is something there's not a lot of literature research going on this, and there's a lot of technical solutions, there are a lot of wish lists, but these foundational principles, not a lot of research on this. Is something which I completely came up with. Maybe there's some thought on this, but I just came up with it myself. So I was just thinking it would be amazing to get some views, thoughts on it, and expand on it further. So thanks a lot for this platform, and hopefully get some comments on it.
Thank you, Harsha, and for your suggestions on how to improve the regulatory environment. But I just want to add one thing, that software costs also come under capital expenditure. Only the maintenance costs come under O&M. So most regulators are allowing the software cost or the ERP cost or any software under capital expenditure. So unless the regulator finds it that it is not required, right? It is not prudent to do that expenditure. Otherwise, all softwares and everything is covered under capital expenditure, and the utility gets a return on the equity portion of the investment.
For sure. I think particularly the larger point being that, of course, I need a much granular understanding of what expenses are accounted for where, but the conversation definitely needs to start on this.
Yeah, and as your suggestion that we may be moving to supply and wire, yes, quite a few regulators are doing the tariff separately, but yes, that in the future we may be moving to that, and we need to segregate our accounts. We are only doing an allocation. Your suggestion is very good that we should separate our accounts. So thank you.
I just want a clarification. This separation of wires and supply. How are you going to do it?
No, that will come when once the law mandates it. At the moment, there is no law mandating separation of carriage and content. Then we will have suppliers like and buyer content will be with the distribution company. The suppliers will be like you can have anybody become a supplier, and he will do the metering, billing, and supply portion to the consumer.
So wires, we are not talking of transmission.
No, we are talking about distribution wires here.
Only distribution.
Yeah, separation of distribution wires.
Many countries have that. Wire and supply.
So the law has not yet been approved?
No, not yet. Not yet. We don't have separation of carriage and content. Thank you, Harsha.
Thank you, Ms. Harsha. Now we will be moving ahead with our next presentation by Ms. Shivali Dwivedi, Energy Technology Specialist, USAID's and SAREP Program, RTI International. The presentation is on exploring virtual power purchase agreements for increasing RE penetration in CNI segment of India. I'll just quickly load the presentation.
This is a very interesting subject to move towards 100% RE, because most of the regulators allow say 70 to 80% of the sanction demand. So the rest can be met through virtual PPAs. I'm sure she will be able to explain what virtual PPAs are.
Good evening, chairs, and good evening, everyone. I'm Shivali Dwivedi, working as Energy Technology Specialist under the USAID SAREP program. SAREP stands for South Asia Regional Energy Partnership, and this program is being implemented by RTI International. So, to begin with the presentation, my objective and the purpose of submitting this paper at ISGF was to sensitize the stakeholders about this concept of virtual power purchase agreements. So the discussion about this topic has started picking up in India, but sensitization, it needs to be done that what the concept is and how it can benefit the Indian stakeholders. Moving on, what is a VPPA? So just let me explain the operating mechanism of a VPPA. It's a power purchase agreement that is signed between a CNI consumer, the commercial or industrial consumer, and a RE developer. And under this virtual power purchase agreement, there is no physical transaction of electricity between the developer and the consumer. Only the green attributes, which are in the form of a renewable energy certificate, they are sold by the RE developer to the CNI consumer. And since there is no physical transaction of power between the two entities, hence the name virtual power purchase agreement. So where the power actually goes that is generated by the RE developer? The RE developer can sell its power on the power exchange in the form of a brown power. Now again the question comes that why as a brown power, though it is generating green energy. So here we need to understand that it has already sold the green energy attributes in the form of a renewable energy certificate to the consumer. So if it sells power again on the power exchange is a green power, then this will lead to double counting of the renewable energy attributes. Hence, the RE developer can sell the power on the power exchange as a brown power in the day-ahead market or the term-ahead market, as the case may be. And for the CNI consumer to meet its physical power demand, it can continue to buy power from the DISCOM, the distribution company. So, like the DISCOM will not lose their heavy demand or the heavy paying consumers in this case if a virtual power purchase agreement is being signed between the RE developer and the CNI consumer. Now here a question may arise that why, if the CNI consumer is already buying the physical power from the DISCOM, why does it need to sign a VPPA with the RE developer? So nowadays, like many of the corporates and the industrial entities, they are getting into signing the sustainability targets with the aim of going to RE100. So with this mechanism, with this procurement of RECs from the RE developer directly, they will be able to meet their sustainability targets and achieve the target of RE100. The payment settlement mechanism under VPPA, the basic principle of this operation is CFD, so which stands for contract for difference. In India, this term is being called as bilateral contract settlement, which is BCS. Under this VPPA agreement, the CNI consumer and a RE developer, they sign the agreement at a firm strike price. So whatever the REC, the renewable energy certificate that the consumer will be buying, he or she, the industry will be paying a firm strike price to the RE developer, and RE developer will get the price of the power sold on the exchange from the power exchange. So here, like, it's a benefit for the RE developer that it will be getting a firm strike price from the CNI consumer, plus it will get the market clearing price from the power exchange for the power that it is selling on the power exchange. And so here the settlement will be based on the principle of CFD. So just to give an example, if the strike price between the two entities, it is ₹4, and the RE developer, it is selling the power on the power exchange at ₹3. So it is getting there is a difference of ₹1 that the CNI consumer will pay to the RE developer just to maintain that firm revenue for the RE developer. So the main purpose of this mechanism is to encourage the RE developer to set up the plant. Like if more merchant plants, they need to come in the market just to have a firm source of revenue for them. This mechanism will play a very important role. And as CNI consumer is buying power from the DISCOM, it will continue to pay to DISCOM against the electricity consumption. But so the next question is that why VPPA should be brought to India, and why is it necessary to bring this mechanism to Indian market? So actually currently there are 4 existing mechanisms through which CNI consumer can purchase RE in India. One being open access, then green tariff, the renewable energy certificates which they can buy from the power exchange, and then the power exchange itself, the GTAM and the GDAM market. So currently there are few issues, or I would say challenges, that are existing in these 4 RE procurement mechanisms, which I would like to highlight in the next 2 slides quickly. As you can see in the graph on this left hand side, open access, though the open access cost in most of the states, it is at par with grid, or it is even in some cases lower than the grid tariff for the CNI consumer. But there are few challenges that are related to open access. If the consumer is located in various geographies, then it will have to comply to the policy and the regulations of various states, and then there are different open access charges that it will have to pay for transaction in different states. Then there is a financial risk associated with the open access, because there are a lot of charges that are added to it, like there are additional surcharge and cross subsidy surcharge, and there is delay in getting the open access approvals as well. For second RE procurement mechanism is green tariff. As you can see in the graph on the right hand side, there are few of the states that have adopted the green tariff. So in the green tariff, like what is done, an additional green premium needs to be paid to the DISCOM by the consumer for buying electricity directly from the DISCOM. So as you can see, this range for green tariff, it is ranging between 0.5 rupees to 5.5 rupees, which is like considerably it's very high for a consumer to pay that premium rate of 5.5 rupees in addition to what it is paying for its energy consumption. So the challenges that are related to green tariff, one is this itself, that the premium is high. Then there is a limited supply of RE. The DISCOMs, they sometimes struggle to find that RE power and get that contracted to supply to the consumer. And then again there is a regulatory barrier for consumer who are having the RE 100 target, because as per the open access regulations, the RE consumed by a consumer, in addition to the renewable purchase obligation that it has, it will go towards the RPO compliance of the DISCOM. So if a consumer has RE 100 target, it won't be able to meet it simply by buying green energy from the DISCOM through green tariff mechanism. Third RE procurement mechanism is REC, where the consumers can buy directly from the power exchange the REC certificates. As you can see from the graph, that there is a lot of variation in the price and the volume, the clearing price trend of renewable energy certificate. So, and between between July 2020 and October 2021, there was no REC transaction also on the power exchange. So there is a lot of market volatility which is associated with the REC price. So this is one of the challenge when we talk about REC mechanism, and the same goes for GTAM and GDAM mechanism, that there is a lot of price volatility which depends on the supply and demand mismatch. As you can see on the graph, from the graph on the left hand side, that the price, it is for the GDAM, the market clearing price, it is going from 4.09 rupees to as high as 9.29 rupees, and again decreasing. So it is like important to note that this 9 rupees, it's only the market clearing price that is discovered on the power exchange. When it is actually being supplied to the consumer, then more POC, point of connection charges, then additional surcharge and other charges are added to it, and which increases the delivery price to like a really considerable high amount. So these were the few challenges that I wanted to highlight about the existing RE procurement mechanism, and VPPA can help in addressing these challenges. Like if we bring VPPA, then these challenges could be addressed. For example, if open access, in open access, we saw that if the consumer is located across different locations, they will have to comply to different state regulations. But in VPPA, even if like suppose a company XYZ is located across multiple entities, then it can aggregate the demand or the number of REC certificates that it wants to purchase and can sign a single VPPA with a RE developer. And in open access, there is difficulty in meeting compliance of open access regulations across various states. There is uncertainty in open access charges, which sometimes makes it financially unviable. But in VPPA, like since it will be a bilateral agreement between the CNI consumer and the RE developer, then because of this, it won't be impacted by the open access regulations that are currently existing. For REC and power exchange, again, we discussed that it is prone to the market fluctuation and depends on the market volatility. But VPPA, since it will provide a firm source of revenue to the RE developer, it is immune to the market fluctuation, and it is assured that the RE developer will be getting the firm strike price at which the VPPA is signed. For the RECs, again, it's the same case as GDAM and GTAM. And for the green tariff, like there is a premium and the consumer needs to pay that premium to the DISCOM. Here under VPPA, the RE developer will be getting the green attributes directly from the, it will be supplying green attribute directly to the consumer, so there will be no involvement of the premium charges. So in addition to addressing the challenges of the existing mechanisms, VPPA can also provide additional advantages, such as it can help in meeting India's 2030 RE target of 500 gigawatt. Currently, the CNI consumer, they account for approximately 50% of the power demand in the country, and out of this 50%, only 7% of the RE, or only 7% of the CNI demand is being met by RE. So if if CNI consumers, they sign more agreement with the RE developers, so this huge margin can be compensated, and then it can be covered, and then the remaining percentage can be met by the RE in renewable energy. Again, for the developer, it can help them in getting a firm source of revenue. So it will help more merchant plants to come up in the Indian markets, which are currently limited because financial institutions, they hesitate in financing the merchant plants. So once they see that they have a firm source of revenue, then the financial institutions will be able to finance the RE developers. VPPA will help the CNI consumer in meeting their 100% sustainability targets going towards RE 100. And since like there are many companies that are announcing that they'll be reaching RE 100 by 2030 or by 2050. So they, in their annual reports, they will have this benefit of showing that against this target through VPPA, they are putting up this plant or a specific plant, and it will reflect in their annual reports also. And lastly, it will help the state governments in meeting their RE targets, because again with VPPA there will be more RE deployment in the state. So yes, it will help in increasing the deployment of RE in the state. In this slide, I have tried to present few numbers and try to present a case study of the various RE procurement charges existing in the state of Haryana, Andhra Pradesh and Gujarat. So like here you can see that the cost of procuring RE under the various procurement mechanisms, it's ranging from 8.70 rupees to 8.5. So from the first three grey bars, they are like the procurement charges from the IEX, and these two charges are the open access charges for the two cases of third party open access and group captive open access. The third party open access is obviously expensive than the group captive open access, because there are different charges that are added onto the third party and they are exempted in the group captive. So here we can see that the price is varying drastically, and it is very expensive for the RE consumers as of now, for the CNI consumers as of now who want to go to RE 100 or want to go clean. So if a VPPA, a strike price is there, and since there will be no actual transaction of the physical power, only REC will be traded. So obviously the cost of the REC trade, it will be cheaper than this. But yeah, like since this is an emerging concept and this is a new concept that is yet to be brought to India, there are few risks also that are associated with this mechanism. The first being financial risk, like how will the consumer and the RE developer will estimate the strike price for the future 25 years. So one of the solution that I have tried to propose is that initially the tenure of a VPPA could be kept as low as 3 to 5 years, and once they understand the operating mechanism and how the accounting and the settlement will be done, then it can eventually over the years, once the mechanism matures, the PPA tenure could be increased gradually. And it is on the CNI consumer and the RE developer to use the best forecasting models to estimate the price, that how the RE price will go down the line and over the years. There are several contractual execution and operational risks associated with VPPA, that what if one defaults, like any agreement that is currently existing, VPPA will also have the same contractual challenges associated to it. So one of the solution which I have tried to mention over here, that the standard agreement could be created that will cover all the dispute resolution mechanism and all the clauses, exit clause if any entity wants to exit from the VPPA. So having a very detailed agreement that will help in addressing the contractual and executional challenges. And liquidity risk, there is a liquidity risk that is associated for the RE developer, that if even though it has generated the power and it has sold the renewable energy certificate to the consumer, what if there is no offtake of the power generated on the power exchange? Then its power will go waste. So this is like, there is no solution to it, but I just wrote that the RE developer can price the power at a reasonable rate, which can be competitive to the market, so that it gets a dispatch in the power market. This is the last slide where I'm proposing the key takeaways and the recommendations. First is establishing operating framework and regulations around VPPA. Once there are regulatory compliances and proper jurisdictional responsibility matrix established in India, then for sure this will increase the confidence of the RE developer and the CNI consumer to get into this arrangement, and eventually then once the regulatory mechanism is set up, this mechanism will start to flourish in India. And second is preparing a standard PPA document, which can be a guiding document for the entities which are entering into a VPPA. So as mentioned in my previous slides, that there are various risks associated. So if this standard PPA document is being brought out by any government agency, then I'm sure there will be a lot of confidence by the private entities to venture into this mechanism. So here I've come to the end of my presentation. Thank you.
Thank you. You've given a very good insight into VPPAs. We don't have them in our country. And my only question to you would be, what would be the price difference between an REC and a green attribute of VPPA? Is there any study on it? I know you wouldn't know that. So
yes, ma'am. Actually, there are a lot of VPPAs happening in the US, and I've tried to talk to a lot of companies who have publicly declared that they are in VPPA in the United States, but they're not disclosing the strike price or the price at which they have signed the VPPA.
It's very difficult to estimate this strike price.
Yes, but this will only make sense if the strike price of VPPA is same as that of the RECs currently.
Exactly.
Then only it will be profitable and it will.
Otherwise, nobody is going to do a VPPA.
Yes,
that's why I asked you what will be the cost difference. Yeah. Okay, thank you.
Thank you, Ms. Shivali. Our final presenter for the day is Mr. Shubhajyoti Majumdar and Mr. Kumar Mayank. Mr. Shubhajyoti Majumdar is Senior Consultant Manufacturing, Logistics, Energy and Utilities at Cognizant Technology Solutions, and Mr. Kumar Mayank is Manager Consulting Manufacturing, Logistics, Energy and Utilities with Cognizant. And the presentation is on smart solutions for strengthening drinking water supply value chain. Just quickly load the presentation.
There is one more insight of harmonics and losses.
I'll just share this with our online participants also. Yeah, over to you, Shubhajyoti.
Good evening, everyone. I'm Shubhajyoti Majumdar, and I'm joined by Mayank Kumar. We from Cognizant Technology Solutions, and we are from the energy and utility business. We are more than pleased to present the recommendations regarding the most pressing problem that is being faced by the human civilizations of today, the future of drinking water. It's quite astonishing that human civilizations moved ahead from moving via cartwheel and sending bots to Mars, right? And we, from writing letters to we communicating via 5G. And it's quite astonishing that today, 1 out of 3 people globally are lacking access of safe drinking water. It's quite contrasting, right? And it is also evident that the municipalities are spending about 40 to 60% of their energy only on pumping water. So, in a nutshell, we can say that it's about water, but it's not only about water, it is about the water and energy nexus as well. And on top of that, we can see that almost 335 billion liters of water is getting leaked in the networks every single day. And as per CPHEEO norms, a single person can sustain with only 150 LPCD per day. That means if we can leak 100% of it, we can provide almost every one of it, almost around 2 billion people we can provide with safe drinking water. So what we see, the drinking water industry is facing, should I say, a double whammy over here. They don't have enough infrastructure to provide water for everyone globally, and wherever the infrastructure is available, they are facing the problem of leakage, right? So the need of the hour for these industries are to adopt, proactively adopt the smart solutions so that they can plug the leakages and improve their profitability as well, and solve the pressing problems, the 2 problems that we have mentioned over here, the leakage and the water energy nexus. Well, in the previous slide, we touched upon 2 key challenges. If we scratch the surface a little bit, we would see there are few relevant problems that are prevalent in the society. For example, the global increase in the population is quite evident, and so as well in India, we are almost touching 1.4 billion, and if I am not wrong, India is already today the largest populated country in the world. So that has made or forced the rural population migrating toward the urban areas, and has there has been a population influx in the urban areas causing rapid urbanization. Because of this rapid urbanization and over extraction of water, almost all towns and cities across the country are in gray area. By gray area, I mean they are all depleted. They have all depleted water level, groundwater levels. And I need not mention what depleted water level means. It has direct consequence on agriculture and the food. So it is not limited only to water and energy. It is going to water, energy, and food. And all these 3 are the basic necessities of life. And as above, over and above these problems, there are mandates, like global mandates that has been taking place around COP26 or the global warming mandate regarding reduction of energy consumption across the globe. And that is why it is quite necessary, and it reinforces the fact that we need to adopt the solutions quite aggressively going forward for the sake of our future generation. Now I'll take a pause talking about the challenges. I have spent some time talking about the challenges. Let us have a look at the value chain of the drinking water supply. So it starts off, it is a very linear infrastructure. It starts off from the raw water. Generally the raw water comes from a dam, or generally in India it comes from a river in case of surface water treatment. And then the water gets treated in the water treatment plants. It is transmitted through the pumping stations. It goes to the overhead tanks that we can see all around our cities. We see the overhead tanks that are there. And from those overhead tanks, they flow via gravity to the households. And they have house service connections to provide water in the households. So if we can see, the energy consumption is quite lopsided. The energy consumption is concentrated in the upstream. If I may say, I'm taking some words from the oil and gas, but it's upstream. Over here, that means because most of the energy gets consumed by the pumping stations, and that is there in the transmission and the water treatment zone. Well, the distribution zone attributes the maximum leakages. So why does it happen in the distribution zone? That when the water network moves towards the population or the human habitation, the network of other utilities, you have gas utilities, you have electric utilities and water utilities, sharing the common underground area, which you see almost all cases these pipelines would run parallel to the roads, and they are sharing the same area. Whenever there is a repair required for a gas, they would be calling an excavator, and they would be trying to dig it up and go for repair. And in such cases, there is a high chance that there is a utility strike, and hence it causes leakages. Apart from the water theft, that is a concern as well, and mostly so in Delhi. So in this presentation, as well as our paper, we have not only stopped at presenting the solutions, but we have also pointed out the areas of application. So it may be noted that India has adopted a lot of smart solutions through their programs like Jal Jeevan Mission, and places or states like MP, Madhya Pradesh and Orissa has been adopting flow control ferrules that promotes equitable distribution of water in households. Similarly, Pune was one of the first cities across the country to go forward with city-wide AMI water meters. Now, moving ahead, the world is in aggressive manner adopting digital twins for water network, and that is so because it has an overarching impact across the entire thing. If you see the diagram, it has an overarching impact. It can affect the water treatment. It can optimize the dosing of alum, dosing of chlorine. You can get direct feedback of whether the chlorine content of the output is more. You can also get the feedback whether the raw water conditions are too turbid or not, depending on the seasons, depending on the rainfall, and you can directly, it would trigger the operators, and in some cases, if it is in a mature state, it would ask or it would automatically change the dosing of the chemicals. Similarly, we are also focusing on another solution called variable frequency drives, as we mentioned about the water energy nexus, and variable frequency drives hits that problem on its head. So, what is digital twin? Digital twin is nothing but a virtual platform that provides a platform for visualizing all the data that is coming from inline data loggers, which are generally the IoT smart devices like level transmitters, flow meters, or pressure transmitters. And if we put the AI/ML technology and predictive analytics on top of this continuous data stream, we can identify anomaly across the network, and we can proactively hunt the leakage locations. For example, leakage, we can't stop leakages, right? You can go and keep a tab on whether someone is digging up the road or not. But the only way the leakage absolute quantum can be reduced is by proactively arresting the leakage. And that can only be done if the identification of leakage is done as soon as possible, and people can go and make the amendments as soon as possible. So I'm aware there has been a digital twin session today within this ISUW sessions in the morning. Let us digital twin is deservedly a buzzword of today across all utilities. Now, let me take a moment and cut the clutter and explain why is it so. So, digital twin is not a single pill or in a single step that would change the utility operations in a single moment or a single day. It is a stepwise journey. It starts from investing on assets. It starts from investing on the assets that would provide you the data stream that we are talking about. Then it would, and the second stage is predictive in nature. If we use those data for analyzing how the network is actually working, that can benefit the utility as well. In the third stage, it's go on to prescriptive in nature. So when we are overlaying this data stream with AI/ML technology, it can automatically run the algorithms and provide what should be the most optimized operations in place. Now, if we see the first three stages of digital twin, it has a very limited end user perspective. For example, the end user in this case would be someone who is sitting in the command center, who needs to act on it, who needs to act on the command, or who needs to act on what the current situation is, the feedback coming from the devices. When we move on to the fourth stage, it is quite transformative. The fourth stage involves augmented reality, and hence brings people who are in remote conditions or remotely. People who are already trained can provide training to people who are going on ground. For example, people who are going to lay pipes or going to put on the valves or flow meters. They can collaborate, and in some cases, when the network technicians go to the households, they can provide their specific experience and skills to the person who is actually on field. Now, the fifth phase is actually the end goal of digital twin, right? It is automation. So So what happens in the fifth phase is it gets the data stream, it generates the most optimized operation, and through a two-way communication via the SCADA system, it controls the assets directly. So it would control the valve opening, it would control the pump flow and the pump operation directly. And that is the dream state of a water utility. And there are similar dream state, that is the fifth stage across all utilities as well. So I promised I would be speaking a bit about VFD. VFDs are variable frequency drives. It is based on the fact that the water flow demand or the drinking water demand is quite dependent on the daily routine of the households. So we start off for the work around 8 o'clock in the morning, and we come back around, let's say, 6 o'clock, 7 p.m. at night. It's seen the water demand peaks around 8 o'clock. There's a trough in between, and then again it peaks when people comes back home. Now what happens, all the motors as well as the pumps are designed for this peak state, right? Because the peak requirement, based on the peak requirement, the design is made. But what happens if the motor is running 24/7 at that kilowatt rating, we are losing a lot of energy. And research has shown we are losing about 88% of energy overall. So Water Networks that is currently in Delhi, which is running a 24/7 project, has now adopted VFDs, variable frequency drives, and rightly so, because and they have been able to reduce the energy by 88% in the pumping stations. And VFDs have another additional aspect of it, that it can also reduce the effect of water hammers when they're utilized with soft starters. There are a few other smart water solutions that are relevant in Indian context as well as across the globe. I'll just touch upon them because paucity of time. So they deal with satellite-based leak detection system. What it does, it is absolutely suitable for a municipality or a city that is entering into a scheme or a program that deals with a leakage management. It would give a snapshot of the entire city and say, okay, these are the locations, exact locations at which you can find leakage. And this is based on the fact that the reflectivity of treated water is different from a reflectivity of untreated water. So when you take a snapshot in from the satellite, using satellite, you would get a different reflectivity on your photograph, because treated water will show a different response to it. Similarly, as I mentioned initially, that the water industry is facing the problem of aging infrastructure. Now the business needs to take call when and where do we need to replace the pipes, and here is where the leakage condition or detecting robots comes into play. It would recognize the requirement. It would take photographs going inside the pipeline, and it would identify and map, compare with the best pipe conditions, and recommend, and that would enable to take informed decision for the management. The third one is equitable water distribution. That depends on IoT. A lot of solutions depend on IoT rather than SCADA programming. Equitable water distribution is based on the fact, again, for social equities for it, as well as engineering, and it involves engineering as well. For example, a water network, a single branch, for example, our overhead tanks that is flowing water via gravity downstream, sends water to an elevated location, elevated village, or some places that are not at that height. So what happens, because the nature of water will flow towards the area that is located below. And the equitable water distribution comes into play over here. They are providing flow control valves that is connected to the SCADA, and then apportioning the water based on the flow required as per the number of people that is catering to in the different zones. The fourth one is vacuum excavators. It is quite essential from the point of view of safety. As I mentioned earlier, that utility strike is an issue across utilities, and it is used, instead of using buckets, they are using pneumatic air to address this problem. AMI water meters, on the other hand, provides an opportunity for the utilities to connect with the end users directly, and provide them direct consumption graph, so that they can have confidence and can generally they are associated with invoices, automated invoices as well. Now, looking ahead, the end goal of any technology or innovation is for securing a sustainable future. The utilities and water authorities, that mostly municipalities in the country, needs to aggressively adopt these solutions, not only to save their money, not only to get profitability, not only to plug leakages, but to save natural resources on earth, that is water and energy. With that hope in mind, I conclude my presentation. Thank you. Thank you for your patient ears.
Thank you, Mr. Mazumdar and Mr. Mayank. It was a wonderful presentation. We are all looking forward to Har Ghar Nal Yojana and getting water to every house. So smart water solutions will become very important in the future.
Absolutely.
Thank you.
Thank you. We'll be happy to take questions, or if anyone wants to discuss, we can do it in the later part of the day. Thank you. Thank you for your patience. Yes. Thank you.
Thank you, Shubha Jyoti and Mayank, for the presentation. Now, I would request our chair and Murugeshan sir if they have any final remarks for the presentations.
No, I would just like to say that we have had a very wide spectrum of discussions on smart energy meters, smart gas distribution, smart water distribution, robotics, and AI, everything, and BPPS and regulations. So I think this has been a very broad spectrum discussion on each and every aspect of smart being smart in today's world. And I thank every presenter for giving a new, very good insight into what they are saying. They were very lucid, and it has given us a lot of ideas. Smart communities was an added dimension which none of us think as engineers. So thanks to Madam Purnima for giving us an insight into smart communities. I think we have done very well. So
thank you, ma'am. Now I would like to pass the ball to our audience. If they won't have any remarks or questions or any ideas. Okay. So yes, ma'am. So requesting chair of the session, Ms. Anjali Chandra, to felicitate our speaker. Oh, yeah. So Shubha Jyoti has something to say. Can we have the mic, please?
Sure. I think it is audible for everyone, right?
Yeah. But it's not audible for our online members.
I'll just make a small comment on this. There's a misconception that smart technologies are driven by urban areas, right? And there's a misconception that most of the smart projects are happening in and around the cities. But success of any smart program depends on its application across the locations. For example, if we see the program of UPI adoption across the country, it is successful today because it is adopted at some of the remotest locations across the country. So smart solutions needs to go to the rural areas. It has reached in the urban areas of today in India and across the globe. To make it successful, because most of the population lies there, if we need to make it grand, we need to reach to the rural areas as well. I think that is where our focus should be right now, and Indian government and other authorities aided by the funding agencies like ADB and World Bank are funding projects that focuses on adopting such smart technologies in rural areas as well. Thank you. It was my 2 cents on that topic. Thank you.
So I would request one by one, and ma'am, please can you come in front? So Mr. Manas Kundu had a flight to catch, so he will not be here for a picture. Would like to invite Mr. Harsh Raj for the memento of thanks. Please come in front, Harsh. Thank you for the presentation. Ms. Purnima ma'am. Ms. Harsha. Thank you so much, Harsha. Thank you. Ms. Shivali. Mr. Digambar Singh. Thank you. And Mr. Rashid was online, so felicitating him virtually. He is there. And next, Mr. Shubha Jyoti and Mr. Mayank. Please come in front, sir. And with that, I would like to request Mr. Emil to kindly felicitate our chair, Ms. Anjali, with a token of thanks. And Anjali ma'am to please felicitate sir. So thank you to our chairs. I can't thank enough. It was an end time. And all our speakers, all our authors for all the efforts that they have put in their papers and presentations and coming here. We'll have a group photo, ma'am. I'm so sorry to call you again here. We'll have a group photo with all our presenters as put in efforts.